Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is the conversion of alcohols into aldehydes, ketones, and carboxylic acids, a genuinely reagent-dependent reaction that JEE tests constantly. Let's begin. A primary alcohol has its hydroxyl-bearing carbon attached to exactly one other carbon, and oxidizing it removes hydrogen atoms in a specific, controllable sequence. Using pyridinium chlorochromate, PCC, a genuinely mild oxidizing agent, a primary alcohol is oxidized only partially, stopping cleanly at the aldehyde stage, since PCC specifically cannot push the reaction any further. Using a genuinely strong oxidizing agent instead, like acidified potassium permanganate, or acidified potassium dichromate, the reaction proceeds all the way through to a carboxylic acid, since the aldehyde intermediate formed is itself immediately further oxidized under these harsher conditions. This reagent choice is exactly the single most tested distinction in this entire topic. PCC equals aldehyde, strong oxidizer equals carboxylic acid, and it directly reflects PCK's specific chemical inability to oxidize an aldehyde's own remaining CH bond any further. A secondary alcohol has its hydroxyl-bearing carbon attached to exactly two other carbons, and oxidizing it using either PCC or a strong oxidizing agent produces a ketone, and critically, this oxidation genuinely stops at the ketone stage regardless of which specific oxidizing agent is actually used, since further oxidation would require breaking a carbon-carbon bond, which ordinary oxidizing agents simply cannot do under these standard reaction conditions. Tertiary alcohols, with their hydroxyl-bearing carbon attached to three other carbons and genuinely no hydrogen atom remaining on that specific carbon, cannot be oxidized at all under these normal conditions, since oxidation of an alcohol fundamentally requires removing a hydrogen atom directly from that specific hydroxyl-bearing carbon, and a tertiary alcohol simply has none available to remove. A classic JEE trap is presenting a reaction with PCC and expecting students to reflexively predict a carboxylic acid when the correct answer is genuinely the aldehyde, since PCK's whole defining purpose is stopping precisely at that intermediate oxidation stage. Another frequently tested trap involves tertiary alcohols placed in an oxidation reaction scheme, where the genuinely correct answer is that no reaction occurs at all. To solve these problems reliably and quickly, first classify the alcohol as primary, secondary, or tertiary by counting carbons attached to the hydroxyl-bearing carbon, /, then check the specific reagent. PCC always signals mild aldehyde stopping oxidation for primary alcohols specific, while strong oxidizers push primary alcohols all the way to carboxylic acids. And remember that secondary alcohols reliably give ketones regardless of which specific reagent is actually used. Let's recap. Primary alcohols oxidize to aldehydes with mild PCC, but all the way to carboxylic acids with strong oxidizers like acidified potassium permanganate or dichromate. Secondary alcohols oxidize to ketones regardless of reagent strength, since further oxidation would require breaking a carbon-carbon bond. And tertiary alcohols simply cannot be oxidized at all, since they have no hydrogen on their hydroxyl-bearing carbon to remove. That's alcohol oxidation to aldehydes, ketones, and carboxylic acids. Keep the PCC versus strong oxidizer distinction for primary alcohols sharp. It's the single most tested trap in this topic. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.